The sea at night can be a place of mystery and wonder. For centuries, sailors have told tales of encountering waters that shimmered and glowed. Imagine their amazement. These stories, passed down through generations, spoke of vast stretches of ocean alight with an ethereal glow. Sailors called it Milky Sea or Mareal. Some were afraid. They thought it was magic or monsters. Others saw it as a good omen, a sign of safe passage. Early naturalists and explorers documented these glowing waters in their journals. They speculated about the cause. Was it phosphorescence, the light emitted by some substances after exposure to light? Or was it something else entirely, something alive? They were on the cusp of a remarkable discovery. These glowing seas, we now know, are the result of countless tiny organisms called dinoflagellates. These single-celled creatures, adrift in the vast ocean, possess a remarkable ability. They can produce their own light. This phenomenon, known as bioluminescence, is a testament to the incredible diversity and wonder of the natural world. The sailors of old, witnessing this spectacle, had stumbled upon one of nature's most dazzling secrets. They had seen, perhaps without realizing it, the magical dance of bioluminescence. Bioluminescence is not confined to the ocean's surface. Descend into the depths and you enter a realm where light is scarce, where the sun's rays fade into an eternal twilight. Here, in this alien world, life has found a way to create its own illumination. In the deep sea, bioluminescence is not a spectacle, but a necessity. It is a language of survival, spoken in flashes, flickers, and glows. Predators lure unsuspecting prey with glowing appendages. Prey, in turn, use flashes of light to startle and confuse their attackers. Creatures of the deep use bioluminescence to communicate. Some species signal to potential mates with intricate patterns of light. Others use bioluminescence to attract symbiotic partners, forming alliances in the darkness. The deep sea, shrouded in darkness, is anything but silent. It is alive with the language of light, a symphony of bioluminescent signals that illuminate the depths. The secret to bioluminescence lies in a remarkable chemical reaction. Two key ingredients are involved: luciferin and luciferase. Luciferin is a molecule that, when it reacts with oxygen, produces light. Luciferase is an enzyme that facilitates this reaction, acting as a catalyst. Different organisms have evolved different types of luciferin and luciferase, leading to a spectrum of colors and intensities. Some creatures emit a steady glow, while others produce flashes or pulses of light. The control of bioluminescence is equally fascinating. Some organisms can regulate the intensity and duration of their light emissions. Others have specialized cells or organs, like miniature lanterns, that concentrate and direct the light. Bioluminescence is not a single phenomenon, but a symphony of chemical variations. It is a testament to the power of evolution, shaping life in the most extraordinary ways. The deep sea is home to a dazzling array of bioluminescent creatures. Perhaps the most iconic is the anglerfish. This fearsome predator dangles a bioluminescent lure in front of its toothy jaws, attracting prey with the promise of an easy meal. Jellyfish, with their pulsating bells, create mesmerizing displays of light as they drift through the water. Some squid use bioluminescence to camouflage themselves, matching the light filtering down from the surface and making them nearly invisible to predators below. Even the smallest creatures of the deep, like copepods, play a role in this underwater light show. Their bioluminescent flashes, though tiny, can be so numerous that they create vast, shimmering waves of light. The deep sea, once thought to be a barren wasteland, is teeming with life, much of it glowing with an otherworldly light. It is a constant reminder that we have only scratched the surface of our planet's biodiversity. Section 5. Nature's Fireworks. Bioluminescence is not just a spectacle of the deep. It can be found in a surprising variety of environments, from terrestrial caves to freshwater lakes. Fireflies, perhaps the most familiar bioluminescent creatures, light up summer nights with their flickering signals. In some caves, glowworms spin sticky webs that shimmer with bioluminescent light, attracting unsuspecting insects. These tiny creatures hanging from the cave ceiling create a scene straight out of a fairy tale. Certain species of fungi, known as foxfire, emit a faint but eerie glow in forests at night. This bioluminescence, though not fully understood, is thought to attract insects that help disperse the fungi's spores. Bioluminescence, far from being a rare curiosity, is woven into the fabric of life on Earth. It is a reminder that magic exists in the natural world, if we only know where to look. Section 6. Bioluminescence in our hands. Humans have long been fascinated by bioluminescence. For centuries, we have harnessed its power for practical purposes. Miners once used fireflies to illuminate their tunnels. Soldiers in World War I used bioluminescent sea creatures to read maps and signals in the trenches. Today, bioluminescence is a powerful tool in scientific research. Scientists use bioluminescent markers to track the movement of cells and molecules, providing insights into diseases like cancer and Alzheimer's. Environmental scientists use bioluminescent bacteria to detect pollutants in water and soil. These bacteria, engineered to glow in the presence of specific toxins, provide a sensitive and cost-effective way to monitor environmental health. Bioluminescence, once a source of wonder and mystery, is now a valuable tool in our quest to understand and protect our world. Section 7. A light under threat. As we continue to explore and exploit our planet's resources, we are increasingly encroaching on bioluminescent environments. Light pollution from cities and coastal developments threatens fireflies and other terrestrial bioluminescent creatures. Pollution from agricultural runoff and industrial waste can disrupt the delicate balance of marine ecosystems, harming bioluminescent creatures and the habitats they depend on. Climate change, with its rising sea temperatures and ocean acidification, poses yet another threat to bioluminescent life. We are only beginning to understand the complex web of life that supports bioluminescence. It is our responsibility to protect these fragile ecosystems and ensure that the magic of bioluminescence continues to illuminate our planet for generations to come. Section 8. Illuminating the future. Despite these challenges, there is reason for hope. Scientists are making strides in understanding and harnessing the power of bioluminescence. This knowledge could lead to breakthroughs in medicine, environmental monitoring, and even sustainable lighting. Imagine cities illuminated by bioluminescent trees, eliminating the need for energy-intensive streetlights. Picture hospitals using bioluminescent imaging to diagnose and treat diseases with unprecedented precision. Bioluminescence could revolutionize the way we interact with our world, offering sustainable and efficient solutions to some of our most pressing challenges. Section 9. A bioluminescent world. Bioluminescence in all its forms is a testament to the beauty, diversity, and resilience of life on Earth. From the tiniest dinoflagellate to the largest jellyfish, these creatures remind us that magic exists in the natural world. As we continue to explore and learn from these luminous organisms, we unlock secrets that could illuminate our future. Let us strive to protect these fragile ecosystems and harness the power of bioluminescence for the benefit of all living things. The future can be bright, lit by the gentle glow of nature's own light show. Let us work together to make this vision a reality.